do this. Okay. So I know you can laugh at the title. It says 2.6. Please change it to 3.3. It's because when I take documents and merge them together, sometimes it... Yeah, I have to turn that off. Yeah. So derivative of a constant. What we're doing, I'm going to do a lot of this graphically and refer back to the notes we did this morning. But the derivative of a constant, if I have a function that looks like this, what is its slope? Power rule. We heard this one this morning. If we take the exponent down, and then what do we do to the exponent? Good. And if I have a function multiplied by some constant, like if I graphed y equals 3x, the slope is 3. Now here's how I can do that using this rule. I put a 1 up next to the x, and all I do is drop the 1 down and put the 0. Now what do you think I do with the 3, Mr. F? All you do is leave it there. So the derivative of that is 3 times 1, 3x to the 0. 3x to the 0 is just 3. So if you have a constant out in front of a function, what you're supposed to do is to leave the constant alone and just take the derivative of the function itself. So you're thinking, we'll do a whole bunch of examples on this in a second. If I have two functions and they're being added or subtracted from each other, I just take the derivative of each of them separately. That's what this rule is saying. So if I have two functions and I'm adding them together and I'm subtracting them from each other and I want to find the derivative of it, I just take the derivative of one of them and I add it to the derivative of the other one. Yeah. All the limit rules. And that's where they come from. Yeah. Well, it's the apostrophe on the keyboard, isn't it? Isn't it just like when I'm using it, I use shift, not shift. I think I just use that button there. Yeah. You mean like this? That symbol? It means not. That's what it means. Anyways. Okay. So we have 4 rules that we're going to use today. So if somebody says find the derivative of x cubed plus 6x squared minus 5/3 x plus 16, we're going to use these 4 rules to do the question. So find dy over dx, that just means find the derivative. So I'm going to do this in 2 steps, even though that eventually you're going to be like me and you're going to look at it and do it all at once. So the derivative of x cubed, take the 3 down, x to the power of 2. The derivative of 6x squared. So what I just said was leave the 6 alone, cover it up with your thumb. What's the derivative of x squared? 2x to the 1. Okay, minus 5/3 x. Okay, so put the 5/3 down, cover it up with your thumb, and then look at the exponent on the x. It's a 1, even though it's not written there. That becomes 1x to the 0. Plus, what's the derivative of 16? 0, because 16 is a constant. So when we clean it up, and this is what I mean when I talk about skipping steps, I will go from the question to the answer, and you will see on the page just this. Oops, dy over dx equals 3x squared plus 12x minus 5/3, and you're finished.
So it will always be like the height will go down like 1 degree, maybe?
Yeah. Yeah. Yeah, we'll do it again and again and again, and eventually, if it's a polynomial, it'll become all zeros.
Is it always, if it's, so if it's like x4, you like you start with 4, you multiply this by 4, what do you want?
Yeah. Okay, next one. So you look at it and you say, Mr. App, I don't like fractions. Fractions scare me. Now, I'm going to do this two different ways. I'm going to do it as, I'm going to rewrite it like this. Same thing. Dividing by 4 is the same as the 1/4 fraction. dy over dx equals, ignore the 1/4, just write it down. What's the derivative of x to the 4? 4x to the 3. Plus, ignore the 1/8, just write it down. Times to the 1. Do we need to put the 1 there? No, but I'll put it there just for kicks and giggles. Put the 5 down, ignore it. Remember that there's a 1 up on the power of the x. So it's 1x to the 0. Hard? No. So dy over dx equals, hardly, yeah, I know. Okay, so you get x cubed plus 1/4 x plus 5. Now, are you scared that I go from here to here, or I will expect you to go from there to there eventually? No, I don't think it's too much to ask either. Okay, next one. Mr. App, I don't like fractions, they scare me, so I'm going to write it as y equals 5x to the negative 2 plus x to the negative 1 minus 3 before we start. So all I'm doing is flipping stuff up. So, do you guys want to jump to the answer? What is it then? Negative 10x to the negative 3 plus no. There you go. Negative 1x to the negative 2. Do you need anything at the end? No, because it'd be plus 0. We can put it there. We'll put it there in yellow because that would be cool. So then you could, Mr. App, could I switch it back into fraction form? So dy over dx, you could write it as negative 10 over x cubed minus 1 over x squared. Now, depending on the AP exam and the question of the exam, I argue that both answers are correct. So you're just going to have to look for both of them. Both won't be there. Only one of the two will be there. But yeah, this is multiple choice. Yeah. Yep. You would receive full credit for either answer. Okay. Flipping page. So, Mr. App, square root, I don't like it. Switch it into a power. Y equals x to the 1/2 power plus 3x minus 1. So the derivative of that is 1/2 x to the negative 1/2 plus 3 times 1 x to the power of 0. I'm not going to skip any steps on this one just for, I don't know, annoyance. So your A correct answer would be this one. Or this one. Yeah? Now, I don't know if they'd ever be evil enough to do this, but yeah, I guess you could see that. I wouldn't expect it, but I don't know why they would do that. I just multiply top and bottom by 2 root x, and I get a common denominator, and I add. So I don't know if I'd expect that. I'm just putting it there just to be prepared to extend your brain a little bit sometimes. They might. Okay, it sucks. But anyways. Okay, next one. Give me something you can do first before we actually take the derivative. Could you write it as x squared over 2x? Could you write it as 3 over 2x? Now, why can you get away with that? Because there's a common denominator? Because there's a monomial denominator. Can you simplify that for me? Are you comfortable taking the derivative when it looks like that? Some people are nodding their heads. Some people say, Mr. Epp, I would like to do one more thing with this. So you might want to do this. That might help. What freaks you out is I'm able to do it with this one, but I've been doing this stuff for years, so I can look at it and do it in my head. So the derivative, dy over dx, equals, how many steps do you want this in? Just one in the answer, or none? One in the answer? So just copy the half down, times 1x to the 0, plus, copy the 3/2 down, and then it's negative 1x to the negative 2. Now you got to remember that it's not a minus, it's a negative, right? So maybe we'll put it up here as a negative so we don't forget. So dy over dx equals 1/2 minus 3 over 2x squared. How does that sound? Yeah? Okay, so finding tangent lines. The results from part E to find the equation of the tangent to the curve. Okay, so what we just found here was the derivative. So we know y. Okay, so we know y is that, and we know dy over dx is this. I gotta zoom out. Zooming out. So we know the curve passes through the point 1, 2. We would like to actually find the slope now. How do you find slope? Plug what in? Yeah. One half minus 3/2 is negative 2/2, negative 1. So the equation of the tangent line is y minus y1 equals mx minus x1. Y minus 2 equals, and what's m? Negative 1. Support your answer graphically. Okay, well.
So all we have to do, we don't have to do the y as well.
What? I'm just giving you the equation of a line. That's the easy way of doing lines. You want to write it in y equals mx plus b form?
No, when you do y over dx equals 1 now, minus 0 to...
That tells you the slope. Yeah, that tells you the slope. That's not the tangent line. It just tells you the slope. The line that touches the curve at the point 1, 2. I'll draw it. It looks like this. No, take that one off. Okay, y equals clear that out. Bracket x squared plus 3, close bracket, divided by bracket, 2x. Okay, and then I'm going to plot that line, so I have to move the blue 2 out. I have to move that 2 out, so it looks like this. Take the 2 over to the other side. Okay, window. So window, I don't know, I'll use zoom 6. So there's the function at the point 1, 2. So we should see the curve just touching at the point 1, 2, does it? It's tangent there then. So that tells you the exact equation of the line that touches the curve at the point that you're interested in. Yeah. Yeah. Is that all right? Cool? Sam? Just a little bit? You're looking a little funky at me right now. What's going on? But what's bugging you? Oh. Okay. Milo. Exactly the same. This is just the fast way of doing slope. The f prime of x equals the limit as h goes to 0 is the slow way of doing slope. Okay. Does the curve have any horizontal tangents? If so, where? Horizontal tangents. Horizontal. What is that? What does horizontal mean? What kind of slope do horizontal tangents have? Slope of... So I would like to know where the slope equals 0. So can you find a formula for slope? Yeah, Mr. Epp, it's called the derivative. Take the derivative of that, please. Hello? What's the slope? Plus 0, right? Okay. And then we're going to make... So what we do is we say set that equation equal... that function equal to 0. Okay. Factor that. What can you take out? More. A 4n and x. X squared minus 1. Factor it some more. So it's got horizontal tangents at 0. Well, okay, so 4x equals 0, or x plus 1 equals 0, or x minus 1 equals 0. One would hope that you don't need that line. X equals 0, x equals negative 1, x equals positive 1. But that makes sense. If you draw a quartic, a power of 4, in the air with your fingers, it makes a W shape. It always look what? A U? A tooth. Oh, okay. Okay. A tooth as in, okay. A tooth. Well, I don't do my own dentistry, so... Yes, okay. Okay, this... Most people think it makes a W. Hey, look, it looks like a W. Or a tooth if you want to do your own personal dentistry. And can we see the horizontal tangents? Can we see the flat bits of the curve? They're at -1, 0, and +1. If I wanted to get the y values, how do I do that? If I wanted to know, because if I say if so where, if I say give the coordinates, you need to get y values. Where do you go in the function to get y values? Do you go into the derivative or do you go into the function itself? The function itself. So let's be clear on that. So if at the very end I want to know the y values, you need to go into the function. Oops. So in the function. Okay. B, flip the page. What? Do you want me to do those? So when x is 0, y is 0 to the 4th minus 2 times 0 squared plus 2, 2. When x is -1, Mr. Up, I'm really lazy. You're right. So am I. Second table. When x is -1, y is 1. When x is +1, y is 1. Use a calculator. Anyways. Determine the x values where the curve blah 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 has horizontal tangents. Okay, so what's the derivative? Sure, I was just going to say 0.8. And then what's the next one? Right? Okay, factor it. Smiling. Of course I'm joking. Factor it. Who wants to? Okay, so what I would like you to do is to type in your graphing calculator y equals 0.8x cubed minus 2.1x squared minus 4x plus 5, and I would like you to find the x-intercepts. I would like you to find the x-intercepts of that function, please. So you throw that on your calculator, you hit graph. This is the graph of the derivative. So how many x-intercepts does this curve have? How many? How many? How many? 1. Did I put it in wrong? Oh. Well, you guys are all wrong. I hate you. 7! Crap. Epic fail. That works on so many levels. Anyways, I'm going to go cry now. That counseling's really going to be effective this week. Second, trace, 0. Yes. No. Left bound, right bound. Guess. Close enough. So, 1.86, 22222. So we have x equals -1.86. 2 is repeating. Next one. What is it? 0.9484, sure. What? Yeah, well. I'll tell you on the test. 3.5388. 3.5388. So those three x coordinates will have horizontal tangents. So if I graph the quartic function, the power of 4, I know that at those 3 points, I'm going to have that W-ish where it changes. Now, I'm ish drawing, so you just have to accept the fact that I Okay. More differentiation rules. Okay, so the product rule. You got to be careful here. When you have two functions being multiplied together, it is not the derivative of one times the derivative of the other. It goes like this. It is the derivative of the first function. It's almost like the distributive property, really weird like. The derivative of the first function times the second plus the derivative of the second function times the first.
Or for short, U prime B.
Derivative of the first function, or the first bracket, times the second bracket, plus the derivative of the second bracket times the first bracket. Yes. I will give you one, but I don't know if the AP exam will allow you to use it. I have to get an old AP exam and look at the cover. That's part of my homework this weekend. If the AP exam doesn't allow it, then I won't. The quotient rule. The quotient rule, the derivative of the top function times the bottom function minus the derivative of the bottom function times the top function all over the bottom squared. How do you figure it out? Yeah, actually I let kids prove those as bonus marks. Okay, differentiating a product. So I have two functions. I'm going to say u is x squared plus 1. And I'm going to say v is x cubed plus 3. So I want you to tell me what u prime is, and I want you to tell me what v prime is. I didn't change anything. I misunderstand. Thank you. What's u prime? What's v prime? Okay, so f prime of x, all we're going to do is put all the pieces together. Derivative of the first, 2x, times the second, x cubed plus 3, plus the derivative of the second, 3x squared, times the first. Hard? No. But do you notice how I'm saying it? I'm not using u's and v's. I'm using words. I'm saying the derivative of the first, times the second, plus the derivative of the second bracket, times the first. I don't use u's and v's. I have not memorized the formula with u's and v's. I've memorized it with words. It makes more sense to me. Yeah. Not usually. Let's do another one over here. Come on, folks. I just made another one. Times the square root of x plus 7 plus and you're done. If you're depends, like I said, it's multiple choice. You're going to have to go and find the answer that matches. They're not going to have both. So, you betcha. Well, that would be mean. That would be mean. So, is it really that bad? Derivative of the first times. I'm not making you prove the rules. I had to. So way back at the beginning of the notes, when the power rule, I had to prove that for my calculus course. I also had to prove the product rule and the chain rule. We haven't heard about the chain rule. The product rule, the power rule, and the quotient rule. I had to prove all those three on a test. Yeah, first semester, first year calculus course. So don't. I'll say it. Bitch at me. I'm giving you the rules. Okay. But like I said, I might have that as a bonus question on the test, but it's really easy. You just look it up in the formula. Look it up on the web. It's also in your textbook. Find y prime of 2 if u of 2 equals 3. Okay, so y prime of 2. So what we're saying is y is u times v. So y prime is going to be the derivative of the first times the second plus the derivative of the second times the first. So it asks you to find y prime of 2. Y prime when x is 2 is u prime when x is 2 times v of 2 plus v prime when x is 2 times u of 2. So all you need to do now is drop in the numbers where they go. Running out of colors. Drop the numbers where they go. -4 times oh yeah, -4 times plus times 3. 6 minus -4 plus 6, 2. How we doing? Yeah. They're not hard. They're warm and fuzzy, aren't they? Yeah, but I'm not going to make the test any longer. Okay, differentiating a quotient. We'll stop after this one. Now, you know what? Let's see. No, let's do it. Let's do this. This is easy. The only weird one's the quotient. Okay, so we're going to flip back and forth from the rule. So I'll put the rule here. What? It's open to that page? So I don't need to put the rule down now. So u equals x squared plus or minus 1. So u prime is 2x. V equals x squared plus 1. V prime is 2x. Okay, I'm going to write the quotient rule down. Yes, I know you can see it on your page, but I'll do it for my benefit. F prime of x equals u prime times v plus minus v prime times u all over v squared. Now, I don't remember it that way. I remember it, now watch how I say it. The derivative of the top, it's more words, but it makes sense. The derivative of the top times the bottom. You know what I mean when I say top and bottom? The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Which makes more sense to you. So instead of, if you don't like that, you can do this. Top, top, bottom, bottom. Same thing. Do you like that better? The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. If you use u and v, use u and v. I don't... I'm not... So t is 2x. B is x squared plus 1. B prime is 2x. bt is x squared minus 1. This one's engineered to work out beautifully. So, unfortunately, we have to simplify, or fortunately, we have to simplify this. 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 1 squared. So you get 4x over x squared plus 1 squared. What? At the very end? No. Well, that's really bad. Okay. So that one can be cleaned up. Usually quotients clean up pretty nice. A little bit. Okay. Second and higher order derivatives. So this is what we were talking about. Find the first four derivatives of those. So y prime, tell me what y prime is. 3x squared minus 10x. Okay, what's y double prime? What's y triple prime? 6. What's y quadruple prime? So when we go past, and if you're wanting to be cool and write it another way, you write it as dy over dx, and then d squared y over dx squared, and then d cubed y over dx cubed, and d to the fourth y over dx to the fourth. Those mean the same thing. One's Leibniz, the other one's Newton. The chain rule? Okay, the chain rule is brackets within brackets. So when we see, no, yeah. It's just the power rule over and over and over again. So there's 3 rules we learned today. We learned the power rule. Let's flip to the front. Power rule. Okay, I guess we learned more than 3. Those 4 rules are important. Derivative of constant is always 0. The power rule is the key one on there. And then the constant times a function, you just put your thumb over it and do the derivative of the function and then lift your thumb up. And then we had the adding and subtracting, and then we learned about the product and quotient rule. So I guess there's 5 rules we learned today. I will give you it as a formula sheet, but I'm not confident. I know I'm not confident whether or not the AP exam allows the formula sheet. So I'll let you have it. I'll give it to you, and you can use it, but I don't know about during tests. Okay, Spence? Because I have a really cool formula sheet. I'm quite proud of it. Of things to be proud of. Uber Super Formula Sheet version 2.1.1. Because it's treasure. It's pirate gold there, baby. Anyways, so it's got all the rules. It's got all the rules that you probably don't even know about, and some more. So I'll give you this, but like I said, I don't know if the exam will allow you to use something like this. Anyways, okay. So there you go. Yes.